Alright, let's look at the concept of kinematics, displacement, time, and velocity. So we have the definition of kinematics. So we can define kinematics as a branch of classical mechanics which describe motion of points, bodies, objects, and system of bodies, that are a group of objects, without the consideration of the cause of motion, that is the force. Now we know that in physics that is force that causes motion. So without us considering the force that causes the motion, we can say that is kinematics. So without the consideration of the cause of motion. So we can also say that kinematics as a field of study is often referred to as geometric motion, and the word geometric is talking about shapes. So let's consider the diagram below. So normally we are familiar with this diagram. We are familiar with probably something like this in our elementary school. So we can say that to find the the hypotenuse region is by using Pythagoras theorem, by saying that the square of the two sides of the right angle triangle is called the square of the hypotenuse. We're still familiar with that. So we need to get the formula in order to proceed further. So we have something like this. Using Pythagoras theorem, we can say this is r squared is equals to x squared plus y squared. We have this, that is if it's starting from the origin. If it's starting from the origin, this is what we're going to get here. So this is Pythagoras theorem. Also we can use SOHCAHTOA. We're still familiar with this, whereby he's showing us the relationship in the sine part and the cos and in the tan. So we can say this is sine of the angle here, which is theta. Sine of angle theta is equal to the ratio of the opposite side to the hypotenuse, which is p. So to represent it using y and x, opposite side, which is my y, over my hypotenuse side, which is my r. Similarly, we have cos of the angle theta, which is the ratio of the adjacent to the hypotenuse, which is p. So what's my adjacent side, which is x, over my hypotenuse, which is radius r. And the last one, we have tan theta is equals to ratio of opposite to the adjacent, adj is equals to what do we have? This is y over x here. So we need to know these formulas in order to solve kinematics. This is talking about geometry. So let's see an example. Now remember that since we mentioned that this is the formula Pythagoras because it's starting from the origin, assuming this part is not an origin, like it's not 0, 0, then it's going to be a different case entirely, because the numbers or the thing you're going to use is going to be different. But here we're just considering when it's starting at the origin. Alright, so let's see an example. Let's say we have an example mention that the Cartesian coordinate of a point xy plane let's say we have an example. Let's say we have x and y is equals to 3.50 meters and let's say 2.50 meters. Come on, now to find the polar coordinate. Alright, we're asked to find polar coordinate of the point. Right, polar coordinate of the point. Now this question is very easy to solve. Alright, we have solution here. Now we have difference between Cartesian coordinate and polar coordinate. Now in Cartesian coordinate, we'll make use of x and y, xy, but if it is in 3-dimensional, xyz. But in this part is two-dimensional we're looking at. So in Cartesian coordinate, measure of x and y, and the Cartesian coordinate is they given us to be 3.50 meters and 2.50 meters. All right. Now, how about the polar coordinate? The polar coordinate, polar coordinate makes of r and theta. That's if you did previously, most of this are this theta and the radius, which is the hypotenuse side. Okay, so at this point here, for the polar coordinate, I'm going to represent with r and theta for polar coordinate. But assuming it's Cartesian coordinate, we have to represent it. It's going to be x and y here in this pattern. But here, so they want us to convert this x and y to polar coordinate. So let's see how we can do about it. Right, so next we have to find this and this here. So we don't know the answer yet, but we can solve it. Now remember that we have this formula. We can apply this formula here by saying this is r squared plus is equals to, so sorry for that, this is x squared plus y squared. This is r squared is equals to x squared. What do I have in x squared? This is 3.5 squared plus y squared is 2.5 squared. Yeah. Wow, sorry, about 2.5 squared. About 2.5 squared. So next, if we square it, we're going to have, if we square it, we're going to have, sorry, I just my camera very well. So if we square it, we're going to have, this is 12.25 positive 6.25. So add this, we're going to have 18.51 meters. So if I say r squared is equals to taking the square root of both sides, or this is 8.51 meters. So taking the square root of both sides, we say r is equals to the square root of 18.51. This will give us approximately 4.3 meters. So we have r here to what? 4.3. Yeah, 4.3 meters. Yeah, this is my area. So next, what are we going to get for the angle theta? Now we can still say that tan theta is equals to the ratio of y by x. And what's my y? My y is given as this is my y here, given as 2.50 divided by 3.50. So this is tan of this, we have approximately 0.714. So we say theta 0.4. I say this is theta. This is, sorry, let me adjust my profile. So if I have theta here is equals to 0.714. Take the tan inverse of 0.714, should get an approximately 5.5 degrees. Yeah, so we can represent it back here to 5.5 degrees, and that's my answer. That's convert the Cartesian coordinates into the polar coordinates. Yeah, this is my answer. Thank you very much, and see you guys in my next video. Don't forget to like,